we'll see some examples on normal distribution. So before starting some examples, we'll recollect what we have done, and already I've shown you the tables also which we are going to use in the normal distribution. Here the area will be given, so we are going to find, this is the area, in this part area will be given, and on this corner and above the z values will be given. That means if I say z value is 1.96, so we have to look under 1.96 here. We'll take the value of 1.96 here, 9 here, and under 6, that is this here. This will be the value which is 1.9, under 6 is 0.4750. Right? So if z value is 1.96, then we'll take the value as under 1.9 under 6, which will be 0.4750. So now we have to see how to find out the z value. So already we know we'll find z using x minus mu by sigma, where mu is mean and sigma is standard deviation. Now using these normal tables and z, where z is known as what? Standard normal variable. Now an example. So yes, we have given x is a normal variate with mean 30 and standard deviation is 5. So we have to find the probability of 26 less than or equal to x less than or equal to 40. Like we have discussed earlier, we'll write down what is z. So z is given by x minus mu by sigma, and here given mean is 30 and standard deviation is 5. So given mean is equal to 30 and standard deviation sigma is equal to 5. Now using these values we'll find out first z values for these corresponding x values, then we'll use the normal tables and find out the value. So what we have, first I'll take x1 is given as 26. So for using the formula we'll have z1 is equal to x1 minus mu by sigma, which is equal to, what is x1 value? 26. So using 26 minus 30 by 5, right? So z1 is equal to x1 minus mu by sigma. On simplifying, this z1 value is equal to minus 0.8. So z1 is minus 0.8. Correspondingly, we'll find out z2 value for 40. So x2 is equal to 40 and z2 is equal to x2 minus mu by sigma, which is equal to x2 is 40 minus 30 by 5, that is 10 by 5, so which will be equal to 2. So z1 value is minus 0.8 and z2 value is equal to 2. Now we'll find out the distribution, find out the probability. Now probability of 26 less than or equal to x less than or equal to 40 will be probability of minus 0.8 less than or equal to z less than or equal to 2. As discussed in the previous video, I've shown you how to find out the z values and corresponding how to plot the area in the given values. So what we have now, if I take the values on the graph, okay, so we know that this is the normal curve where here z is equal to 0 and this is divided in two equal parts. This side is 0.5 and left side and right side both are 0.5. Now we'll plot these points on the scale. So this is minus 0.8. I'll take somewhere on the left side as minus 0.8 and plus 2. So somewhere here I'll take 2. Now I'll identify the region. So Z is defined between minus 0.8 and 2. So this is the area we'll consider in the normal curve. So we know that a normal curve is a bell-shaped curve and the area is covered between minus 0.8 and 2. Now in this normal tables we'll find out what is this minus 0.8 value and 2. So what we'll write here? So this is equal to probability from minus 0.8 less than or equal to z is less than or equal to 0 plus probability of 0 less than or equal to z less than or equal to 2, right? Minus 0.8 to 0 and 0 to 2. Now we can write this as what? By symmetry, 0 less than or equal to z less than or equal to 0.8 plus probability from 0 less than or equal to z less than or equal to 2. Now from this graph we'll find out what is this value of 0.8 and 2. So here what we have is, so here we have 0.8 value. So here under 0.8 and under 0.8 and under 0.02, because the value is 0.8 we have to see. So 0.8 under 0 is 0.2881, right? And now we'll see the value of 2 under 0 again. So 2 under 0 is 0.4772. So we'll write the values 0.2881 and 0.4772. So this value will be equal to 0. We got the value as 0.2881 plus, and under 2 the value is 0.4772. As I've mentioned earlier, you can find these normal tables, and using the normal tables we can find out the value. Now adding some these two values, what we have? 0.765. So here given mu value is 30 and standard deviation is 5. Same example I am taking, where we have to find probability of mod of x minus 30 greater than 5. Right? So already we know that when it is given mod of x minus a less than b, right, we can write this as, this imply a minus b is less than x is less than a plus b. If plus is included, inclusive of plus also we can take. That is, if this is equal to, then here also we can write equal to. So now using this identity, we will find out probability of mod x minus 30 greater than 5. Now you can write this as what? 1 minus probability of mod x minus 30 less than or equal to 5. Now using the same identity, here a value is 30 and b value is 5. So we can write this as what? 1 minus probability of 30 minus 5, so 25 less than or equal to x is less than or equal to 30 plus 5 is 35. So we have to find 1 minus probability of 25 less than or equal to x less than or equal to 35. As discussed in the first bit, so here also we have two values, x1 is 25 and x2 is 35. So if I find out what we have, so if I take x1 as 25, then corresponding z1 value will be what? x1 minus mu by sigma, which is 25 minus 30 by, and sigma value is 5. So this will be equal to minus 5 by 5, which is equal to minus 1. Right? 25 minus 30 is minus 5. Minus 5 by 5 is equal to minus 1. Similarly, x2 is equal to 35. So z2 will be equal to x2 minus mu by sigma, which will be again 35 minus 30 by 5. So this will be equal to what? 35 minus 30 is 5. 5 by 5 is 1. So now if I write down this 1 minus, if I change it to standard normal variable, then this will be minus 1 less than or equal to z less than or equal to 1. Now we will find out probability of minus 1 less than or equal to z less than or equal to 1. Similar way we have found in the previous question. So here again I'll plot the value here. So what we have is, in the normal curve, And remember, it will never touch the x-axis because x-axis is the asymptote. So z is equal to 0, and we have -1 which is taken on the negative axis, and z is equal to 1, I'll take it on the positive axis. So he has given that z will lie between -1 and 1. So I'll take the area between -1 and 1, right? And already I've told you that it is symmetrical. That is, whatever we have it on the left side, the same we'll have it on the right side. So I can write this as what? 1 minus 2 times of probability of 0 less than or equal to z less than or equal to 1, right? So whatever the area value we have on the left side will be the same on the right side. So now I'll find out for 0 what is the value. So this is equal to 1 minus 2 of, I need to find the value of z under 1. So now if I see the value of z under 1 under 0 is 0.3413. So using this 0.3412 into 0.3413, and on simplifying this 1 minus 2 into 0.3413, we have the value as 0.6826. So he has given the weights of 800 students are normally distributed with mean 140 pounds and standard deviation 10 pounds. Find the number of students whose weights are between 138 and 148. So here he has mentioned to find the number of students, right? He did not ask you to find the probability, but we have to find the number of students, that is out of 800 students whose weights are between 138 and 148. So first I'll write down what is given. He has given n value as 800 and mean is given as 140 pounds. So mu is equal to 140 and standard deviation is 10. Right? So he has given n is 80, mu is 140 and sigma is 10. So first if I take x1 is equal to 138. x1 is 138, then z1 is equal to x1 minus mu by sigma, that is 138 minus mu value is 140 by 10, right? So 138 minus 140 is minus 2, by 10 will be minus 0.2, right? Similarly x2 is equal to 148, so z2 is equal to x2 minus mu by sigma, so this will be 148 minus 140 by 10, and this will be equal to what? 148 minus 140 is 8 by 10, which will be equal to 0.8, right? So first we'll find out the probability value. So if I define x as weights of the students, random variable x as weights of students. So we have to find the probability value between 138 and 148. So 138 less than or equal to x less than or equal to 148. As discussed earlier in continuous random variable, this inclusive of equal to or not included doesn't change at all because it is a continuous random variable. So whether we take it equal to or not equal to, it's the same. So this will be equal to probability of minus 0.2 less than or equal to z less than or equal to 0.8, right? So same way we'll plot the normal curve. Right? Now this is z is 0 and here on right hand side it is minus 0.2. So somewhere here I'll take minus 0.2 and this is 0.8. I'll somewhere take it here on positive side, and this is the area selected. So from here again we'll see what is 0.2 value. So if it is not visible, we can download normal tables, right? So they are available. So under 0.2, under 0.2, under 0 is 0.0793, under 0.8 it is 0.2881. So this value will be equal to 0.0793 0.0793 plus 0.2881, and adding this value we have the probability value as 0.3674. Of 800 students, the number of students weight between 138 and 148 pounds. 138 and 148 pounds will be equal to 800 into this value. So this is equal to 800 into 0.3674, right? So multiplying 800 by 3.3674, we have the value as 293.9. But since we are talking about students, we'll take this as approximately equal to 294, right? So the number of students whose weight between 130 and 148 pounds out of 800 are 294. So here he has given only one value. So we'll see how to find out. X is equal to, that is weight is equal to 152. So Z is equal to X minus mu by sigma. So we have taken the same example. So mu is 140 and standard deviation is 10. So 152 minus 140 by 10. And with 152 minus 140 will be 12. 12 by 10 is 1.2. So Z value, corresponding Z value for X equal to 152 is 1.2. Now we have to find the probability of X since given more than, greater than 152. Like I told you, equal to, included, not included doesn't change it. So probability of X greater than 152 or simply greater than 152 will be probability of Z greater than 1.2, right? Because corresponding value is 1.2. Now if I plot the normal curve, so using the same procedure, so Z is 0 here, and here Z value is greater than 1.2. So I'll take the value 1.2 somewhere here because it is positive, and since it's mentioned as greater than, the area will be covered will be on right hand side of 1.2, right? So this is the area covered. So now how to find out this area? Since it is tending to infinity, this total area, that is on right side and left side, we know the total area is 0.5. So 0.5 minus this part, this area will give us this part, that is between this part. If I take 0 to 1.2, then I'll get the area required greater than 1.2. That means 0.5 minus probability of 0 less than Z less than 1.2, right? So the total area is 0.5 minus this part, that is area from 0 to 1.2 we have to find. So this is equal to 0.5 minus, now I need to find the value for 1 point. So 1.2 under 0 is 0.3849. 0.3849, right? So 0.5 minus this area. Now this area is 0.3849. So 0.5 minus this area will give us the required area, which is greater than 1.2. So this is equal to 0.1151. And we have to find out from 800 students how many students' weight is more than 152. So of 800 students, weight more than 152 pounds is 800 into 0.1151, right? On multiplying 800 by 0.1151, we have the value as 92.08. And like I've told you, since we are talking about humans, so we'll take the approximate value as 92. So 92 students' weight is more than 152 pounds. Thank you.